In part 1 of our story of evolution, we demonstrated the facts of evolution. In part 2, we will explore the mechanisms. And to do that, we need to ask and answer just 2 questions. How does variety arise in the genomes of individuals in a group? And how does that variety give rise to new species? The first question is probably easier to answer, so let's work on it first. Let's start with the genomes of 2 individuals who are clones of one another. Their genomes are as close to identical as the real world allows. As these individuals live their lives, their genomes encounter viruses, which implant their genetic material into that of the host, thus making the 2 genomes no longer identical. The 2 genomes will also encounter radiation and mutagenic chemicals in the environment, which further modify their genomes differently. Transposons already resident in each genome will modify their genomes differently as well. The process of DNA replication isn't perfect, and the mistakes that arise in this process will further diverge the genomes. If these modifications happen in the DNA of the egg or sperm cell, then they are passed on to the children. In addition to those mechanisms for introducing variety into a genome, sexual reproduction has its own mechanisms to ensure diversity. This man has 2 complete sets of chromosomes, one from his mother and one from his father. But when it comes time to give a single set to each offspring, his 2 sets recombine in different combinations. The same is true for this woman. So when they have children, each child gets a unique combination from each parent. This greatly diversifies the genome of each population every generation. Now that we understand how variety can arise in individual genomes, we are prepared to tackle the second question. How does this variety give rise to new species? There are 2 major answers to this second question: natural selection and genetic drift.